Um, so this is raylib-apl, a simple cross-platform library to develop graphics applications. And I will be talking about first introducing myself, and then I will introduce Raylib, what's that about, and I will also be introducing some example code, comparing, or with one example being with QuadWC, and then a new example with raylib-apl, just as a good comparison. And I will also be showcasing some Raylib examples that are not made with raylib-apl, but that could be made that I just haven't converted to APL. And I will also be showcasing extra features with raylib-apl. And I will, of course, leave time for questions, hopefully. Now, Raylib is the same thing as raylib-apl, because all raylib-apl does is call functions in Raylib. It has over 200 functions for a variety of things, and it's made in C. It was made by Ramon Santamaria, who's from Spain. And its original design was to teach games programming, but it has grown to a lot more over the 10 years it's existed. And I will now explain the features of it. First of all, the graphics features, which are the main parts. It's spline support, which are curvy lines. You can draw those. You can import images and graphics, textures, alongside shaders, which is asking the GPU to execute some GPU code. That part is not raylib-apl, of course. That will be some GPU code that's imported by raylib-apl. Or rather, Raylib, but the same thing pretty much in this case. It has font supports with custom fonts, and sound support where you can even manipulate the sound data yourself. And you can have 3D objects move around a scene, and with bones, with like models. And yes, let's see if I mentioned everything. Yes. And now that's all graphics. This is all I/O, so input-output. It has tons of device support. For example, mouse, keyboard, touch, with even controller support. And I will clarify VR later, but it has VR stereo support, meaning only visual modifications that help Raylib be displayed for VR headsets. But it doesn't have anything for interacting with a VR headset device. That would have to be, that isn't supported by Raylib. And it has amassed quite a following, with having 21,500 stars on GitHub. And it also supports quite a lot of platforms. As you can see, Windows, Linux, Mac OS, FreeBSD, Raspberry Pi and Raspberry Pi Desktop, Android, and HTML5. This is still talking about Raylib, by the way. Raylib-apl has issues currently which make it only appear or work on Linux. But hopefully those will be fixed in the future. And theoretically, Raylib could run in the intersection with this and where Dyalog APL can run. Meaning only where both are supported, of course. Now, I want to explain what led me to create libraries with Raylib, especially my passion for game programming, which is what led me to where I am today. First, this is the simplest game This is a simple game I started out with making. One of the first I made with APL. It starts out with defining answer, and then you also define a function that's called ask, where you query how many numbers you guess correctly. For example, you have a sequence of numbers, and then it says one of these is in the correct place. This is similar to Mastermind, if you know that game. And of course, more example, and this would then be a possible correct sequence, and then you win. I guess all correct. And well, my passion for APL really grew because I could express such fine programs. Now, getting away from that, that's how I started with APL and my introduction to it. Then I wanted to make games because that was really my passion. That's what I want to do. So I made this example with QuadWC, and it's. I will now show you the code for this. It is. Let's see. First, it's the top. This is just initialization. It's defining black and blue colors as 0 and 255. I define stripes, which are 16 by 16 boxes, where it switches between black and blue. And then I make a form, which is a window in QuadWC speak. I then make a bitmap, where stripes here, which was defined above, is the bits, which means the image data. And here is the, oh, sorry, I skipped a line. And this takes that image and adds it as a picture to the form at position 0, 0, meaning adding it to the window. This is an attempt at a per frame, meaning every 60th of a second, meaning the quad DL reciprocal of 60. I modify the bits, meaning the colors, and rotate them by 1 every time this executes. And I do that 200 times. I wouldn't call this idiomatic code, especially because QuadWC was not made to do this. But as you can see, the image flashes. I don't know if you noticed the first time. And when you make quite complicated things and you want to modify pixels and display whatever you want anywhere dynamically, this gets quite frustrating. So I switched from QuadWC. In fact, I switched from APL. I had to make the games I wanted to make. And I then got asked to make raylib-apl. Wait, sorry. This is... Oh, right. So first I will show you the raylib-apl version of this. Screen 2. It fills the entire screen nice. And that's a smooth 60 frames per second with stripes going along as proof before. But notice no flashing. Then now I want to show you the code for the raylib-apl version, and it's quite different. Now, raylib-apl, this is not the entire code, by the way. This slide is the initialization. The next slide will have the loop. As you can see, I just import it. I do path to the file, and then I quad fix it. I don't use link because this is with Dyalog script. I prefer using Dyalog script on Linux. And this is the same kind of format as before, but in raylib-apl, colors are a list of RGBA. So R, red, green, G, and B, and then that's blue. So 255 blue, and this is alpha, meaning if it's invisible or not, or how invisible and see-through it is. I do 8 take, and this is a consequence of a bug I have in raylib-apl, where you need to pad zeros to some data, sadly. I will attempt to fix that in the future version. And here you can see positions. This is a bit more complicated. It is the numbers from 1 to 11, negated by 1, so we start at 0. And this is index origin 1, by the way, just so everyone's aware. And I multiply by 32 to make it spacing between each stripe be 32 pixels. And then this is the quad WC form, but in raylib. I initialize the window at position, well, with size 800, 800, and say the name of this window is hello, exclamation mark, exclamation mark. This is the initialization of the window. Next, I will show you the per frame to function, and this is way larger than before, because raylib-apl offers more control and granularity, and it's all controlled by function calls, no objects or anything. We do for every function, for every frame till the user closes the window, while not the window should close, because this is a until loop. I'm saying until the window should close, I increment the pauses, which is the x of the stripes, so I'm moving them along. And then I do pauses mod, so whenever they reach a certain length or distance, they loop back. But this would make it so that they would move to the end, and then the outline of it would suddenly flash away. And I don't want this. I want there to be a smooth cutoff. Now, I could maybe do some positioning with the size of the rectangle at the end, but no, I'm doing it in a lazy way. I'm saying I'm starting a mode. Let's first go to the begin drawing, because we of course need to initialize the drawing before we can draw. The begin drawing here says that we're setting up a new frame to draw on, and we want a black background, so we're clearing the background with the color black. If you don't clear the background, there tend to be relics of previous frames on the window. Could be useful. I know Asher has used it to only draw once and then reuse frames. Now we begin the scissor mode. This is where the fun happens. We're drawing the rectangles inside a scissored area. This means that we crop out, we take out a slice of the window, and then we only draw on this slice, and then we put it back. We do not affect anything outside of this scissor, this chunk of the window. And the size of this, or this is the position, and this is the size, meaning it's from 0, 0 to 255, 255. Now we draw the rectangles. The rectangle takes 1, 2, 3, 4, 5 arguments. The position, which is concatenated with the rest of the arguments, because the only dynamic argument is this. These are all static arguments, so it's the y, which is 0, the size in the x, which is these stripes are 16 pixels wide, and the height is 256 to down. Then the color of these stripes is blue. Then I draw each of these, which hopefully makes sense. It means that I'm drawing each rectangle as a stripe. End scissor mode, because you need to begin and end everything, every context, because what happens is we're beginning a drawing context, or rather, I think Morten used scope. The word scope might be better here. Begin drawing as a scope, and then we're saying inside the scissor mode, which is another scope. And then we exit these scopes. I also make sure to draw the FPS here. Then we end the while loop, and then we close the window. Finish program. And as you can see, it's no objects at all, because we're literally creating every frame. And you might be thinking, could this be performant? Like, there are lots of function calls, and there is, I wouldn't say we're doing a lot of logic, but there could be lots of overhead with each of these calls. But, I mean, there's one way to test it. We can set the target FPS to so that the end drawing doesn't delay, because by default, end drawing delays so that you're executing one frame every 60th of a second. But I can change that with this line. And after you do this, it's with screen 3. It tends to, it's a bit faster. So yeah, it's not too slow. I think it's fine. And now I'm going to show a duck example. This is going to be a 3D duck, screen 4. This is going to be a new example. This is now I'm not going to show any quantum BC because this is going to be 3D. 3D duck with a logo as texture. I don't know if you can recognize that logo. And then a grid at the bottom being the floor. Now, let's go back. So, that's the duck. Now, this we need to initialize. We're saying the window is sized 800, 800, named hello. We disable the cursor. We don't want a cursor moving around when we want to move around with the camera. And now here are a bunch of comments illustrating each argument here. The position, 50, 50, 50. The point we're looking at, and the up vector, meaning we can also, by raylib, define which side angle we're looking from. And then we also have a projection. In this case, you just do camera perspective. The projection basically means, are we seeing from an eye outwards, or are we seeing from a screen straight on? And it makes a difference when looking at objects that are close by. That's the camera. Then we also load a model from an object file, a 3D model, which is the duck, of course. I'm going to show you the layout, and then I'm going to show you what's in this red drawing place. Next slide. We're saying for every frame till user closes the window, we're looking for the keystrokes from the user to move the camera. That's automatically handled by this update camera function, taking in a camera and giving it back. So we're redefining the camera, which has just a bunch of numbers in a list. Now we're going to start drawing. I will show that after. End while, and then unload the model, freeing up the memory it takes up, and application finished. Now, the drawing is this. It's begin drawing. We're clearing the background with white background. We're drawing the FPS. And then we're beginning mode 3D, so it draws 3D stuff relative to the camera. Then we're drawing the grid at 2010, meaning the size of the grid. It always draws at position 0, 0. Then we're defining the position of the model and the scale of the model. And we're drawing the model with a few arguments like position, scale, color, and the model itself, of course. We're ending the scopes very well, ending the drawing. And now that's the code for the duck, which, in my opinion, is way simpler than opening a game engine, you're just going to Unity, importing a file, somehow getting movement of a camera working. I like this a lot better. Now, I'm going to show the duck again, just to remind you how it looks. It's actually pretty nice. It's a smooth model. It's not pixelated. It's high, what's it called? I think it has a high quality. And now I want to, how much time do I have left? 5, okay, good. So hopefully I have time for this. Let's see. VR Showcase is on screen 5. So this, I got permission to show this video made by Matthew Oros. And he is showing off his VR headset he made with DIY things. This is implemented in raylib, pure raylib, not with raylib-apl, of course. This is a 3D scene he made, and he is using a headset to move around in it, even capturing the position of the headset to monitor movement. Very cool. Then I also want to show a raylib showcase video. I might just show a snippet of it because we're running out of time. So raylib has quite a big community. So every year, Ramon Santamaria makes a showcase of games people make with raylib. And it's pretty low level, meaning most of these games are simple and made by, well, not simple, as you can see. They can get quite cool. They are, I don't think any game studios use this, but it's a different kind of paradigm to other game engines. It's pure code, which makes it very good for for APL. As you can see, runners, there are graphics, cool stuff. There's also examples on UI, as you maybe saw for a split second there. And that is with a add-on to raylib. I'll talk about that in a bit. I think I'll end it here, but you may get the gist. It's tons of great community. Then, now extra bits. raylib-apl, I didn't write quad NA arguments to 200 functions, so because I'm lazy. So I made a parser for it. I made a parser for raylib, meaning it parses the information in the header file, which contains which arguments each function gets, and then it automatically gives the information needed to give to quad NA. I get that code, and then I evaluate it. And fun consequence is there are other libraries add-ons. Ray-GUI, which has the GUI you maybe saw. It's very simple. Only square buttons, square scroll bars, nothing fancy like QuadWC can give. And Physac, which is 2D physics. And all of these are now made with raylib-apl. All of them are shipped with it. Well, shipped, work with it. And now I wanted to touch on when you should use raylib-apl. Good reasons is if you want to make a game, you want to make something 3D, and you want control. Either one of these, great reason. Absolutely perfect reason. Bad reasons, you like object-oriented. This is not object-oriented. This is not going to be that dream. If you want a good GUI, no, use QuadWC or something better than raylib-apl. And if you want it in production now, don't, because if you make a mistake, it crashes the interpreter. C programs tend to do that because they segfault. For example, if you draw before starting the drawing mode. I am in the works on making that automatic, the error checks. Anyway, so, recap. Lots of features, I/O, graphics, ducks, stuff, cross-platform. Yes. Questions?